that he has invented four-valued logic, which I didn't know anything about until I looked it up on DVLP 10 minutes ago. But also he made a lot of contributions to the very first terminological knowledge representation systems, or concept languages as they were known back then, which then... Sorry?
German name.
German name?
German, that was the German name for them,
Don't
not the
blame
North
all
American
Germans.
name.
Right.
Term subsumption language.
Term subsumption, yes. And they had names like nickel and, I think, far more influential, classic. So there was a time where all these logics were very highly expressive, and there came a lot of outsideability results. And as one of the reactions, AT&T and Peter and colleagues invented classic, which was a sort of polynomial time logic, and with explanation systems around and so on. And classic was used wrong. It was the one system that was used in real industry to configure stuff and so on. And from that on, he made a lot of contributions to the area in general, but was also a main driver behind Dummel plus oil. I was just thinking, was it plus or and owl too, and so on. So, and he's one of the few people, I forgot to mention, one of the few people who really understand the intricacies of RPF. So, one of the few people out.
Right.
Okay.
So I was forced into understanding the intricacies of RDF because one of the things I did for OWL was figure out how a description logic and RDF can live, if not in harmony, sort of without completely killing each other all the time. So that was kind of an interesting intellectual exercise that nobody's ever implemented.
Michel
An OWL full reasoner?
Schneider?
No, not a
It will be out in a minute.
Yes, right. So, but today, I'm going to talk about linked data. So, as Lily said, I've been involved with the Semantic Web for quite some time in OWL and RDF and other things. And a few years after the term was first used, I don't follow hype very much. I'm sort of jumping into the meat of this thing early on. I don't follow hype very much, and I sort of didn't really hear the buzz about linked data. And all of a sudden I said, oh my goodness, there's all this talk about linked data, and there's action about it, and all this other stuff. I should learn what it is, right? And I went in and said, yeah, gee, what in the world are they trying to do here? Is it bad? Is it good? Is it just hype? Is it actual technical details? Is it meeting a need? Is it meeting an unmet need, right? And sort of from the outside, right? From the actual, not just by looking at what the data is there, but looking at what the people who are trying to push it say about it. And I got kind of upset. And then I said, well, okay, let them do what they want to do, as long as it's not bugging me too much. But then I said, no, this is really, it's not going away. Right? And I should start to worry about it. And then I got a little bit more upset. And then eventually, I got doing other stuff. And then of course, like not so long ago, big data showed up. And all of this linked data stuff, so it seems to have died down a little bit. But it's still not gone away. And, and I was saying, what should we think about linked data, perhaps to see what we should think about big data. So maybe that would be the next version of this, big data, like it or loathe it. But this is about linked data, and sort of when we get to the end, I'll sort of come up with my conclusions of all this. This is not going to be a technical talk, very much at all, and very much a work in progress. And part of the progress is I've looked at the outside and actually looked at some of the data, but there actually is a lot of data out there that people call linked data. And there actually are some people who have actually analyzed the existing data and made some conclusions, and I will talk a bit about that. But it's not really the case that somebody's tried to collect all of the linked data and actually measure what really is there. Okay, and sort of at the end of the talk, I'll talk about a couple efforts to start at that. Anyway. So that's the abstract that you've probably seen, and of course this is all my personal view of linked data, and I'm sure anybody who's behind linked data would disagree violently with much of what I'm going to say. Okay, so however, to sort of set the stage for this, I'm going to have to talk about the semantic web quite a bit. And initially, early versions of this talk had a few slides about the semantic web. And there got to be more and more and more and more parts of the semantic web, so hopefully I'll be able to go over that fairly quickly. But there's a number of things that I have to bring out so that I can contrast the semantic web, which I kind of like, and linked data. Okay. And then the digging deeper is actually what's really out there, and then some final words. And I initially had a fifth part here, which was, if I was made philosopher king, right? But I'm not being quite that great today. And besides which, there's a few things that I don't know what to say. So I'd like to, maybe the next version of this talk, I'll actually figure out how to say some of the things that I think should have been said about linked data, and will be a fifth part of this talk. But not very. So the semantic web. So if you understand the semantic web at all, if you look at it, you realize that Tim Berners-Lee tried to do something very ambitious and ended up producing browsers. Not to say that browsers aren't very interesting in and of themselves, and not to say that they're not very useful, but the web, as it came to be, was all about publishing stuff and using browsers to look at it. And there were quite some interesting stuff in there. Right? But it's not, the web as we mostly see it is designed for us to look at it, by and large. Right? It's not designed for computers to actually take information, take data on that's out there in the web and do really interesting things with it. Now, people have actually done that with HTML pages, and hence we get screen scraping, and hence we get lots and lots of stuff. But that's not the semantic web. Okay. Semantic web, on the other hand, is supposed to be a place where you can actually put data or information, or if you want to be very brave, knowledge, and actually have machines do the right thing with it. Now, of course, we can't get machines to do the right thing even for very simple tasks. So it's the right thing for some rose-colored glasses of the right thing. Okay? But to do that with as little human intervention as possible. So it's not like we're taking documents and displaying them on screens so that people can read them and buy stuff from Amazon. Right? Or even look at Google Maps or whatever. It's taking data and have computers doing things with it. Okay. Oops. Right. So, how does semantic web work? Well, there's a bunch of W3C recommendations. Let's say, how does it supposed to work? There's a bunch of W3C recommendations, and you write down data, and already have triples that look like that. Okay, we talked about me, and Ian, and various other things. And we use URIs. And these little things with colons in the middle are just shorthands for long, long, long URIs. Why do we use URIs? Well, precisely because they're long, and we can agree that whenever we use one of these long things, it's a global identifier, and that everybody agrees that it's the same name. As opposed to the situation in databases where you have in a database schema, you have a column thing called EMPNM, right? That's a local identifier. It means whatever it means for that database table. Some other database table may have a completely different meaning for EMPNM. Okay. But in the semantic web, the rules of the game are supposed to use these global names, and then all this data is supposed to be available as web documents that people can actually use. Sort of the principles of the semantic web as data. The problem is that data is not sufficient. Computers can't by themselves consume data without having something that tells them what the data is supposed to mean. And, well, you may say, well, don't database systems do things with data without? Well, no, because you program the database programs with an implicit meaning of whatever little bit of the data is, and that's the only way database system works. But we want to do better than that. So here's an example where data alone is insufficient. we say that Alex has heart disease, and we ask who has circulatory disease. A pretty trivial example. Most people would say, well, maybe not most people, because they don't understand circulatory disease at all, right? But most medical persons would say, the answer is obvious. Alex has circulatory disease. Well, maybe on my claim. Maybe I've used the wrong terminology, but, you know. Okay. Why? Why? People say that, well, because they have some background knowledge about these terms. And that's missing from here. But of course, computers have no notion of what background knowledge is. They can't figure out what the world is like. We have to tell them. Okay. So in the data here, there's no connection between heart disease and circulatory disease. We just can't do this. Now, how can we do this? Well, we can write down background information. We can write down the definition of terms. Whatever you want to call it, the name of the word. The tag that's been associated with this ontologies. And I'm sure if we talked to a real philosopher like Bijan, he would cringe when you say ontologies.
No, not anymore.
Not anymore, right? He's been conditioned, right?
Yeah, I'm almost okay with is comprised of as well, but not quite over the cliff.
Anyway, for the purposes of computer scientists, dumb computer sciences, an ontology is just some way of writing down background information about a part of the world, which could be anything, right? You introduce vocabulary, you define the terms, right? And it's all down in some formal language. At least for the purposes of the semantic web, you can make computers actually work with it. It has to be some sort of formal language because computers, common sense and computers don't mix very well at all. So here's a kind of a couple fragments of an ontology, and we're talking about heart and circulatory systems, as you would expect from the previous example. So we're saying the heart is the concept of a heart, right, is a sub-concept of the intersection of a muscular organ and part of that circulatory system. Then we say heart disease is the disease of the heart, circulatory disease is the disease that affects part of the circulatory system. Okay. Now, just note that this is not the semantic web syntax, but if I use the semantic web syntax, it wouldn't fit on one screen. So I'm using some different syntax with exactly the same thing. Okay. So now if we add this ontology in, for a previous example, we get the right answers. We get that Alex has circulatory disease. We also get answers to other kinds of questions. We can actually ask questions of the ontology itself. And everything works perfectly fine. Okay. So we have both data and ontologies, and OWL, or DFS, provide these ontologies in the semantic web, machine accessible meanings, so that computers can actually deduce implicit information, like humans can. Now, I'm not claiming that humans work this way. There's no cognitive verification of this way of doing stuff, right? We work in some way, right? I don't care how we work internally, just that we come up with kind of the same answers. Right? But importantly, the semantic web, because it's this big, amorphous, distributed, and decentralized thing, has a whole slew of problems like this heart disease and circulatory disease. Different sources have different kinds and different amounts of information. They have vocabulary shifts. They have varying specificity. They vary a lot. And ontologies can provide you a way of essentially bringing this back together and linking it. Okay? So ontologies overcome problems in all of these. So the situation is even worse than if you actually just have a bunch of medical people and you want to do background theories for them. You actually have all sorts of other problems with the semantic web. All right. So we have so here's a bit of history. We have the semantic web recommendation of WC started. The first one in 1999 with RDF. Goes back a couple of years before that, but these are just the recommendations. Then we have RDFS, which provides very simple ontologies, cleaned up. We came with OWL for more powerful ontologies. We had a query language and some revisions, and currently RDF is going through a new navel-gazing exercise, trying to extend it in certain ways. That's still ongoing. Okay, but so roughly a decade, a little over a decade of work, and here we are. Semantic web. No linked data yet, okay? But nonetheless, we have data, we have ontologies, we have reasoning, we have everything we need. Right. As far as I'm concerned, right, well, there's still, I haven't talked about everything we need, although I think everything we need is in, there's little bits of RDF and OWL that I haven't mentioned yet. But we have a cohesive story, right? Okay, so just to recap, semantic web, our RDF is data, OWL provides ontologies. global names provide connections. It's written in semantic web documents that you can get using web protocols. Okay. Applications then access and load these documents, process them using reasoners, which you need to do to discover this implicit information, and use it. Well, there's a few, I've glossed over a lot of issues there, but it's kind of a cohesive story. What you need to make this really work is the applications sort of have to know which documents they're going to use. Okay. That's one thing. No, okay. So where does linked data fit in? It seems like things work pretty well. Well, a problem, okay, we have the web out there. Billions or trillions of documents, depending how you count it. We have the semantic web out there. A lot fewer documents, but still quite a few. Lots of different sources of information. If we want to have an application that works over semantic web data, somehow it's got to be able to figure which documents it wants to consume as data and as ontologies. And I haven't talked about that yet. So where's the story on that? Well, so we go back to 2000 and... good question. Before 2004. 2003 is the particular year, but even though it's a bit back. Suppose that we want to give guidance for people who are building applications as to what documents their application should grab. Well, so here's something that was said at one time in the RDF document. If you use a particular identifier, for example, whitehouse.gov, and of course, the web is US-centric, so .gov means the US government as opposed to any other government. President 43, and if you can count that high in US presidents, that's the bad one.
That doesn't narrow it down.
The really bad one. The really bad one externally, as opposed to the really bad one internally, which was a different one who managed essentially to be, all of the people he appointed were criminals, or became criminals, right? Okay. This is the one that terrorized, that essentially took the world almost to nuclear destruction, right? In other words, W, if you George W. Bush, the junior, right? The lesser, whatever, right? Okay. So if you use this identifier, okay, if somebody uses this identifier, it should, at that location, provide a definition of that identifier. Should, right? Okay. So in particular, if we retrieve the document, which this doesn't exist in this case, President 43 from this location, we should have information about the definition of that document, the individual named by that identifier, including things like he's the greatest president ever. Right? Okay. Assuming we go back to when he was still president, and before the Whitehouse.gov changed ownership, right? It would say, George W. Bush is the best president ever. He saved the world from the brink of terrorism disaster, right? Right. But that's part of the definition of this name, right? And it's there, right? That's the definition. Okay? And whenever you use it, you're committing to using that definition. Gee. It works fine for non-controversial things, because if somebody coins a name, they get to control what it means. But anything controversial, why should I believe what Alan says about himself? Right? And this is what we're committing to. It was in the documents. It was proposed as part of the meaning of RDF. But, as I was saying, it's really problematic. And so it ended up being softened. Namely, the first softening was you weren't committed to retrieving and using this defining information, but nonetheless, it still was the definition. And then it actually was completely half-dead. Right. So, okay, there's something. Yeah, right?
Who's me? I got attacked up.
Yes, right. So a
My
little bit more
moment.
history. A bunch of us, Bijan, forefront among this, beat up, got into a room with Tim Berners-Lee and beat him over the head until he gave it. Right? Roughly with lead pipes, right?
Good fun. Good
Yeah,
fun.
it was good fun, right? So anyway, yes. But Actually, I was looking up the history of this, and by the time of the meeting, the requirement to use defining information had already gone from the document. Right? So it had been already softened, and then the meeting essentially just got rid of the rest of it. For a whole bunch of reasons, these and more, right? I mean, there's a whole slew of reasons not to do this. There's also pieces of RDFS itself which essentially says where you could go to get more information about something. And there are two of them, RDFS is defined by, and C also, and essentially is defined by as a way of pointing at what the intended definition of something is, right? But no commitment of actually using it. But it does link an identifier with a place to get the defining information about that identifier, or an identifier with a place to get more information about that identifier. And if that other place actually is RDF data or whatever, and something machine consumable, then you can actually think of actually using it. But there's no commitment. So this is actually, so here we have ways of tying together documents, so we could actually write an application that sometimes followed these links and sometimes didn't. Okay. There's no requirement of using it. It's just out there. OWL itself actually has a way of requiring you to do this. In particular, it's required for when you're trying to do build up logical theories. So we want to have a logical theory of diseases, an ontology of diseases. Well, diseases sort of require a theory of anatomy. Because if you have a disease, if you don't know what the heart and the circulatory system are, it's kind of hard to have diseases of them, right? So a disease ontology really needs to incorporate an anatomy ontology. So OWL imports is the way of doing that, and essentially it's something that requires you to go to this other place and incorporate the information as if you believe it. Okay. I don't think there's anything controversial about this at all. We have an ontology, it requires the use of another logical theory, so why don't you point to that and require reasoners to do that? But it actually was pretty controversial and almost didn't make it into the documents because there were people who protested that this is not the right way of doing it. But it actually made it in. Over protest. And Bijan's boss at the time was one of the protest stores. Yes. So Bijan's organization was on both sides of this. Or all sides of this?
Every side.
Every side, right? As somebody, as an ex-philosopher should be, right?
No, I was only on the right side. Which is also a very philosophical move.
Yeah, all right. That's it. All right. Now, if you remember, there was this follow your nose thing, which essentially said, if you use a name, you're supposed to go to where, you're supposed to actually use that name as an URI and actually retrieve that document and use it. Now, OWL imports can do that, right? Essentially, you have a name, and you just import that document, right? But you can do anything, you can do lots of things. You can not import, you can import from some other places. So OWL imports is a kind of a follow your nose, but more general, right? Okay. And now, what we can do is we could use OWL imports not just for ontologies, but for lots of things. So essentially, we could tie together data sources that require each other, or we could just build a document which essentially has nothing but a bunch of OWL imports. So essentially, it says, we're writing an application, load this document, and the document points out to everything it needs. Okay, so now we have a situation where we can control the use of information. We can link together documents. We can control the use of information in a general way. All right, which is roughly this. Now, so, and this was all back in 2004. So all this stuff was in the 2004 documents. So, Semantic Web sort of starts off, blah, 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 and all of a sudden this linked open data talk starts up. What's linked open data? Well, it's the Semantic Web done right. Or it's a paradigm shift all over again. So, reading that, I sort of say to myself, there really should be something important here. And this comes from Tim Berners-Lee himself. This is from a 2008 talk. There's a bunch of talks, right? Okay. Not just from Tim Berners-Lee, but many documents provide quick introductions to linked data that are meant to describe its underlying principles so that people can use it. So, and this is opposed to what actually exists. So many people have described what is important for the idea of linked data as opposed to what actually linked data actually is. So let's look at what these things essentially mean. Okay, and I'm going to use this from a W3C document to Tim Berners-Lee, where he talks about the principles of linked data, but there's really very little variation. I'm just using this as an authoritative source. Everybody else who talks about it says it's essentially the same thing. So there's 4 rules. Use URIs as names for things. Use HTTP URIs so you can look them up. When somebody looks up a URI, provide useful information. Okay, and then use in your document, use other people's names. Okay, so that we sort of use the same names throughout to some extent. Pretty simple. And of course, when I first said that, but didn't we say this already in RDF? So, and there's another version of this on the same page called 5-star linked open data. Available on the web, with an open license, available as machine-readable structured data, non-proprietary, uses open standards, and links. Right, okay. So here we have the 4 rules and the 5 stars for linked open data. And everybody that I can find who talks about linked data uses this is the core of the linked data. So I look at this and I think to myself, what's new? It's not using URIs as names because that's built into RDF. It's not really using HTTP URI. That was pretty normal. Some people used other URIs, but the use of HTTP URIs was essentially what everybody did. Not interlinking because people did this in RDF. They used other people's URIs. Not machine readable. That's not new either because it's required by RDF. Well, aside from the fact that some of the documents were a little ambiguous, but never mind that. It's not mine. RDF, W3C works in non-proprietary ways, right? It's open standards, all RDF. So what's new? Perhaps an open license for the data. There's no requirement in RDF that you couldn't publish copyrighted data or data which had a disclaimer in the front that says, "Don't use me." And if you have been following the legal niceties of the web, you can get sued for using data that's out there on the web that says, "Don't use me." Of course, this is in the US, you can sue for it. You can sue anybody for anything, right? And win sometimes, right? Okay. Maybe it's a matter of emphasis, that this interlinking becomes more important. Maybe it's this providing useful information for a name or stuff. Maybe. So maybe linked data is just getting some of this social meaning and formal meaning back in, and instead of requiring this follow your nose, just sort of put it up there without any sort of indication that it's really the defining information or whatever. But, all right.
So just perhaps,
Yeah.
can I ask a quick question? When they say on the previous slide, they say link, do they say how to link or what to use to link? Because they don't mean href, do they?
No, they mean use as an identifier, something like http://www.whitehouse.gov/pres43. And when you look up, when you use that URI, you do HTTP get on it. You get a document, and that's supposed to have the right stuff in it.
No, but for the linking, no. What kind of links do we have? Do they say anything about that?
The link is the mention of the name. So it's not like the RDFS is defined by, or the RDFSC also. It's like the old social meaning. When you use a name, you're implicitly linking to that document and grabbing the information from that document.
Mm-hmm.
Okay. So, to recap a little bit. What does link do? It requires, it's sort of, if you're thinking about good things that link data, it requires this linking between different documents. So if you use, if I want to use something about, what's a good example? If I want to use a notion from Wikipedia, right, I should use the Wikipedia URL to talk about that notion, right? Okay. And so the idea is I should use that notion. I should use if I'm using somebody else's notion, I should use their name for it. So Wikipedia has a name for everything that they have. I should use their names as opposed to coining my own names. All right, sounds pretty reasonable, okay, and should have a laudable aspect to the semantic web. But maybe the problem in the semantic web is these things weren't really emphasized because we were worried about logical adequacy and ontology. So, okay, nothing wrong with it. You want to emphasize something, perfectly good. And encourages but doesn't require following your nose, and you can combine data from multiple sources so that you can build mashups. Right, so if you were liking this linked data story, maybe it's an idea that essentially you're promoting this notion that you want to support hackers to build, hackers in the good sense, to build mashups that combine information from different sources. Nothing wrong with that. But the problem with this linked data story is essentially talking about Pres 43 is the same as talking about an ontology name like heart disease, or it's even the same as talking about one of these things in RDF that's sort of logical connective. There's no distinction here, right? They're all just names and you follow them. So I may be able to go from President 43 to something from the White House that talks about all the presidents, or in the same way that as I mentioned heart disease, I go to the ontology for heart disease. Okay? It's the same link, and it just, I want to make a distinction there. Also, because there's only this one way of hopping from point A to point B, we may end up actually using an untrustworthy source, like the White House. Right? If you trust the White House, what was it, 10 Downing Street. If you trust 10 Downing Street, you're sort of in severe difficulties, shall we say. Okay. And also, so we follow our nose to the White House, and the White House points to the military, and that points to the NSA, and all of a sudden you're consuming data by accident that had this disclaimer not to be used by foreign nationals, right? And so you get into severe trouble. And all I wanted to do was follow my nose, right? Okay. Also, so I get to the White House, and the White House uses some ontology language, and I get somewhere else and use a different ontology language, and how am I supposed to do my reasoning, right? I don't know what the language is I'm talking to. Okay. And so when I'm building applications, the guy has to make sure, very careful as to where they go and what really happens. So if you're loathing linked data is a hacker's version that lets you mash up things, but causes all sorts of problems. But if you sort of synthesize so far, what do we have? There's a slight change in emphasis of what's important, and a notion that following your nose can be useful. All right, okay. Nothing wrong, really, except there's all this noise. Right? There's lots of people mention it. There's books, there's workshops, there's websites galore, etc., etc., etc. So, is there anything to support all of this effort? And how much data is there? Well, somebody had been mapping linked open data, sort of essentially major data sets that have self-identified as belonging to this club. Okay. And initially, 2007, there were these guys here. You can see some interesting ones. DBpedia is self-identified as belonging to linked data. US Census has done it. Various people, and that's from 2007. Here's from like last year, much bigger. It's close to 300 major data sets. 300 is not a big number. I think it went to 275 or 375. Somebody can count those, I guess. There's actually a number somewhere here. So that's quite a bit of data. So there's people have actually not just said that we like linked data, they've actually pointed up data. So there's something there, and we can't, I mean, as a researcher, I can't just dismiss it, because it's something that exists out there. And there's also scholarly events. So it's not just that linked data was this thing Tim Berners-Lee and a few other people saying that these are nice ideas. It's a lot of people have gotten on this bandwagon where you're saying this is revolutionary, and it's just got the following in it, right? So maybe there's something more than these descriptions from the outside. Maybe if we actually looked at the data, we could actually see something different. And now we're in the part where this is the work in progress, right? So, but essentially, I have looked in some of the data, and I actually have looked at other people have looked at some of the data, and they have come up with certain conclusions. Okay, I'll mention some other people looking at some of the data and my conclusions from some of the data. So a document from a couple of years ago by a group of people at Wright State looked at the linked data cloud at the time, and their conclusions were precisely that the trouble with linked data is there's just data there. There's no what they would call metadata. There's no ontologies. There's very few ontologies that describe data. So essentially we're in the same situation. We go from Pres 43 to the White House to DBpedia to the census to someplace to something, and there's no description of the data that we've gotten to. And we're eventually talking about U.S. presidents over there, and we may have cycled back to U.S. presidents, but in a different data set that uses completely different vocabulary. So President 43 over there has no connection with George W. Bush over here. Okay? And why should there be? These are different people producing different data sets. They just happen to link in a way that we would like to bring it back together so that U.S. presidents from here and U.S. presidents from there are the same thing, but it just doesn't happen. Very little effort to tie it together. And then, again, we're in a situation where if we're going to be following these links, right, we really have to have program control outside because there's just not enough to tie things together. And we cannot feed it into computers and have them make the right inferences because they're missing the ontologies. They're missing they're missing a whole bunch of things to make the link together. So that's from a few years ago. Maybe things have gotten better. There's actually been a little work to show from the same authors, which indicate that things have gotten a little better, but still this is the situation.
Berta also has a paper where they looked at it and they found a very subset. Was it the same?
No. Berta's, yes.
Yeah.
Berta this year.
Yeah.
A few slides later. Yes, right. So maybe this previous, who's the first author? Jane. Okay. Maybe this has been fixed. Okay. Now, if you do look at the documents about linked open data, it is true that they do mention ontologies in a few places, but it's pretty sparse, right? So you're working in linked data world, I would say that ontologies get heavily underemphasized. There are little bits and pieces. They like to use OWL same as for equality, for example, and a few other things. But in nowhere is there anybody that says, in the linked data milieu, here are the constructs you should be using. Right? And so again, if I'm actually building an application and I'm pulling a bunch of linked data, what reasoner, what tool do I feed this data into to actually get the right answers out? You're on your own. Okay. And again, it's not that linking data is useful, right? It's just that there's big problems in the semantic web with building ontologies, right? Ontologies are hard, right? We need more of them. But the linked data story says, ontologies should only be right. We need better tools for doing things with ontologies. Linked data, you throw together some RDF, you stick it on a document, and you're done. We need even better reasoners than we have now, right? We need good methods for selecting the data, as opposed to following your nose. We need trust, we need whatever. We need ways of accessing data that's on the web in XML or whatever, right? There's lots of XML data that's not translatable yet. We'd like to be able to pull this in and use it in the semantic web. It's not part of the linked data. The linked data story is everybody should publish as RDF, not, oh, you got a bunch of XML data out there. Write a translator or write something. Publish it as RDF. Right. There is, now again, the story's always mixed here, things like this. Some linked data work addresses a few of these problems. So, like lack of ontologies, some people say these ontologies. But again, nothing specific to linked data. So again, here I remain puzzled. You know, what's special about linked data? It just seems to be missing the point. Why are all these people that are working in it? Right? What, you know? And I remain. Well, here's a few problems to it. Right. Maybe linked data is a reaction to the success of success is a strong word. Maybe linked data is a reaction to the pedanticity of the logicists, right? So, again, it's the hacker argument, right? To really work in the semantic web, we got to do reasoning. That's too hard. Right? Requires thought. That's too hard. I shouldn't be white and so negative. It requires global consistency. Not that people who work in the semantic web require global consistency, but there have been complaints about the semantic web that for the semantic web to work, you have to have global consistency, and that's impossible. So let's do something else. Right? And this OWL import is an explicit notion of imports. We need something that's more open, or whatever. Right? Oops. So maybe linked data is a reaction to all of this stuff that those of us who like reasoning and representation have tried to impose on the semantic web. Maybe that's why it exists. But if that's why it exists, then it's up to them to come up with some way of working with linked data, and I'm having real trouble finding that. Okay. And, right, so if you looked at linked data, like actual data that's out there by and large, you get RDFS plus same as or quality and a little bit more. And to do that right is still hard. Right? Nobody does it right. Okay. And we can't say that MapReduce is a solution here. And we need to really still think about, if we believe that linked data is simple stuff plus same as plus, then we still need the tools, and we don't have the tools. We don't have the tools. And so where is the actual reasoning that's going on here? Okay. Now, again, you might argue that reasoning is hard, and therefore we don't need to do it, but the web's hard. There's lots of pieces in the web that are really hard to do right. People have spent, there's a lot of effort to build the correct HTTP protocol so they don't die, right? Lots of effort to build the right browsers so they don't die. Lots of effort to make XML be semi-reasonable, a little bit reasonable, not completely broken. Right. So it's not like, you know, if you want to make something good, it requires work. Right. Okay. And of course, reasoning can be slow, but of course the web can be slow, right? So why would you worry about reasoning being slow? And why would you worry about reasoning being slow when computers are so incredibly fast that retrieving documents lets you do a lot of computation in the time you can retrieve the document?
I need to get somewhere to live.
But maybe the situation is really bad, and that the people around here who like to build reasoners or whatever will never be able to succeed simply because of the mass of data. And therefore, if we're actually going to be reasoning about data in the semantic web, we really have to give up all of these notions of doing interesting reasoning and go back to this RDFS plus same as. And so, and maybe the problem is that our tools are just too slow. So, let's actually look at a bunch of data that's out there that we might call linked data and see what constructs people actually use in this data, and perhaps we can then write a reasoner that works really, really, really fast on this data. Okay. All right. So this is an empirical analysis of the data that's out there that we might call linked data, right? And therefore, and we'll target our tools to that data. Now, that's not what this paper by Bertha Gwynn and authors did, because there's a lot of linked data out there. If we actually slurped in all this BBpedia stuff and all this thing, There's a lot, there's many billions of triples in this data. What's the number? More than tens of billions, maybe like 100 billion. Right? And that's not a humongous amount of data, but it's certainly more data. You need computing resources to actually go through the data. What this paper from Goethe and co-authors did was analyze a crawled set of data called the Billion Triple Challenge from last year. So that's 2 billion facts selected from all of the RDF that's easily available. So instead of tens of billions of facts, or maybe hundreds of billions of facts, you have 2 billion facts. So let's take this as a representative sample, which of course isn't, and do something with it, right? And actually, so what they did is they looked for all of the OWL constructs in there. So let's actually, and all the RDF, they look for all of the ontology constructs in this data. And analyze what ontology constructs are there, and see what reasoning we do. And they actually came up with some interesting results, roughly as follows. So when you actually write down ontologies as RDF, some of the things are simple, like heart disease is a subclass of coronary disease. That's a simple thing to write. Some things are hard to write, like coronary disease is defined as a disease that affects, not coronary. Circulatory disease is the disease that affects a part of the circulatory system. That's actually hard to write down in RDF. So what they found, and it's not actually too surprising, that if you look at the RDF that's out there, most of the things that are out there are the things that are easy to write down. All right. But they actually went through and analyzed the use of this stuff, and essentially came up with an idea that we'll write a new sublanguage vowel which has only these pieces, and design, although they haven't done this yet, build a reasoner that works fast with these pieces. But the results are a little bit encouraging in the sense that the constructs that are out there with any significant number actually can be solved by pretty fast reasoners. And so that's kind of interesting ones. This paper is going to be presented in a couple of weeks, right? Link Open Data Workshop at WWW, which is a couple of weeks from now. Okay, so it hasn't even existed yet. And of course, they actually haven't built the reasoner to see whether it's faster than anything. So here's kind of interesting. So the funny thing is here that some of the constructs that they found that have some significant usage don't appear anywhere in the literature really about linked data. So people who are actually writing linked data use constructs that don't get mentioned in the linked data literature, which is kind of weird. So in particular, if you look at the tools which people actually use to consume linked data, they turn out to be very simple reasoners, most of which can't handle some of these concepts. Even though it's a subset of this protocol OWL RL, which is supposed to be fairly easy. So, maybe what we should do, maybe what the idea with linked data is to concentrate on the data that's out there that people use and to repurpose our energies towards actual data that's out there, and that's what linked data should go. But I don't know if I believe that was right. So, now, if this was a finished talk, then there would, or if there were more people working on this kind of analysis, there would be more papers you could point out that would point more things with linked data. And one of the things I would like to be able to do is actually go through all of the RDF in the web, a lot of it, right? There are crawlers that look for it, right? And do this analysis for everything. But anyway, but let's sort of look back and then say, okay, so now that we've looked at the data and found some little bit, one thing saying there's not much ontology use a few years ago, now there's a little bit more, but essentially it's not very expressive, which is bad because it's not very expressive, but good because we can write good reasoners, perhaps. Okay. Let's actually look at this story again. So we haven't really found much more by looking at the data. We're still back to this thing as what is linked data? Well, it's got some good parts, published data natively and use other identifiers. And let's take those good parts and add them back into the semantic web, which are all these other things. OWL, ontologies, etc., 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 etc. But we don't have anything new here. Right. So again, I'm still puzzled. What's new in linked data? All right, okay. So I see my time is almost up. So, which is good, because now we're at the final point. So, like or so the title of this talk was linked data, like it or loathe it. So let's see what my conclusions from looking at this characterization of linked data and this sort of initial analysis of linked data. Perhaps linked data is really supposed to be data, right? And we shouldn't be worrying about semantic issues or ontologies, and that the idea of machine processable data on the web is the data. Okay, we could argue that that's what people say about linked data, and it is a little bit of a what exists, so it's not quite what exists. So there exists is more than what is said. But maybe we actually should believe these 4 principles and 5 stars, and that's linked data. In which case, it really is move away from semantic issues towards data issues. Maybe linked data is essentially this thing to make hackers, people who build mashups, who build ad hoc tools, make them feel happier with data that's out there. Because the semantic web is all about semantics and high-powered reasoners and building fancy applications that require many programmer years to build even a simple one, but we're not there. We're going to do mashups. Right? Perhaps it's just a marketing slogan. And for whatever reasons, and it's really semantic web. It really is the semantic web. I don't believe that one, but one could argue the following, that the semantic web is this overhyped, loaded thing that turns people off, and therefore we're going to come up with a new slogan, and it'll be better, right? Even though it's the same thing in disguise. And we don't know anybody who does that, do we? Perhaps all of this examination has been overcome by events, and linked data is a buzzword of the past, and we should be ignoring it because everything is big data now, whatever that is. And if somebody can tell me what big data is, I'd sure like to know it. And don't tell me it's the 3 V's. And perhaps linked data is really an honest attempt to try and take us, or other semantic web people, to look at the problems that we've been missing, right? I.e. the problems with data, the problems with implementing. So, well, if they're actually moving away from semantic issues, where I think the problem is towards data issues, which has its own problems, but they're not nearly as much. Right. If it's for hackers, okay, sure, let the hackers be their things, but I'm not going to live there, right? Okay. If it's a marketing slogan, right? Maybe I should like a whole lot for the marketing slogan one, but I don't know. I have on my webpage, I have this allergy to hype, and if you have an allergy and you get sort of exposed to the allergen so much, you lose your allergy. I think I'm losing my allergy. It's an unfortunate state of it. Right? Okay. Maybe it's a buzzword of the past. All right, great. A buzzword has fallen, right? But of course, a new one always comes up to replace it. But at least we got rid of it. And maybe it's an honest attempt to look at some different problems in the semantic web. But first of all, I'm not quite sure what the problems are that's different. And secondly, I don't think that the semantic web people have been neglecting these problems. Right. So anyway, which one do I actually believe is the reality? The middle one. All right, so future work. Really should go back and really look at all the linked data cloud and figure out what's really there, what constructs are used, and what interlinking. There's been some analysis that says the interlinking in the linked data cloud is pretty trivial. You end up in these sinks, which never refer to anybody else. So it's really not a cloud, it's a DAG, right? Or a DAG with unary cycles. Right? Also, if you look at the linked data cloud, what ontology use is there, right? So the paper by Berta, Glim, and the other people looked at this statically, and more than statically, they actually did page rank for some of these things. But really interesting to see which ontologies are actually used where. Okay. And for more data, really challenge. And perhaps most importantly, should people like me, who design logics and build reasoners, and a number of people here as well, should we actually go and do this analysis and find out which constructs are actually used and tailor a reasoner to be really, really, really fast for the data that exists out there? And that's the question.
Any questions, comments, remarks, contradictions?
Bijan! Remember, I put Bijan after.
All day.
I said contradictions right after. I said Bijan right after contradictions because I knew.
Yeah. So one of the things that you in your Loathe list that you kind of missed is that it might not just be a new marketing term for the semantic web, but it might be a part of a power struggle to redefine the semantic web into the good bits and to denigrate everything else. And that would be slightly different, right? And maybe even more loathsome, since I'm on the losing side of that battle. And I should win always. That would be good.
Well, that's a given. Yes, I haven't really thought of putting that down, and if I had thought, I mean, I've never rephrased that. I have certainly thought of that as a possibility, and I sort of neglected to put it down here because I was not just sort of because I forgot when I looked at these things, and of course the slide is also pretty cool. But that's certainly a definite Loathe possibility, right? And it's not like we've never seen these before.
No.
Yes.
Anybody else? No.
So you didn't mention publishing a lot, and in some sense, so I wonder if the thing that you might like in some sense is that linked data is a cat towards data publication, and therefore putting data out there.
I would say that's part of the, okay, so that's actually part of the fifth one that sort of would be useful, right? That essentially, the idea of having this slogan that you can use to stamp on your thing, right? Now, the one problem with that, of course, you could stamp, I mean, our W3C has these RDF and OWL stamps you can use, right? So this would be yet another stamp. So why doesn't the RDF and the OWL stamp work, right? And this new linked data stamp, why should it be better, right? Okay. Now, again, it may also be because of, that's just not on this one, but essentially ease, right? So essentially, to be a good player in the semantic web, not only do you have to put your data out there, but you have to build ontologies to describe your data, right? So this is a way of taking the data part of the semantic web, i.e. the easy part, and letting people get easy stamps. And that's actually quite reasonable, right? Okay, convince people to do something easy, right? So that we can do the hard parts, right?
But that would be okay.
Yeah, but
that would be a foundation.
Yes, that would be okay. That would be sort of something related to the physics, right? Yes.
And then other people can, I look at it, I don't think there's not enough reasoning, there's not enough schema, but in some sense, then different people can come along and build on that foundation.
Yeah.
If there's some published stuff to do.
And so W3C has sort of done this with Griddle, right? So if you've got XML data out there and you have a Griddle translation with RDF, you get a little stamp saying, right? So that's sort of along the same lines, right?
And perhaps it's also, I mean, rather than telling people, all publish your data as RDF data, then how? We don't know, but publish your data as linked data. We have rules to follow.
Yes.
And then
yes.
So you know how to do this. Or at least you could imagine, you could pretend to know.
Right. But the thing that I have against that is there's the divorce between linked data and ontologies then, right? So if you said, publish your data as linked data, not only do we get this data plane here, right? But then you can play in this ontology game where you'll get even more, right? Mm-hmm. So I would like to, if you're making that story, I'd like to say, look, here's the deal. Building ontologies is really hard. Building reasoners is really hard. Here is a step towards that that's easy for you. Well, it's easy technically. There's all sorts of intellectual property and all. We won't go there, right? Okay. So you can just publish your data on there, interlink it, and then it can be used in mashups, and it also can play in this larger review. I'd be much happier than that. Now, maybe that's too long a story, right? Okay, right.
So I was going to say almost exactly the same thing as Norman, but perhaps in a slightly different way. In that I think I'd rather live in a world that had the data there for me to play with than the data not there. And if people publish all this data and then they actually realise the fact that they have millions and millions of different properties and they actually only need 24. And this makes querying much more difficult. And actually, if they actually had some vocabulary, some schema, it would actually work a lot better, rather than just having some people, to use the pejorative phrase, preaching at them. Wouldn't that be much better? Isn't that a good thing?
To some extent, but here's now here's a counter to those first two, to these ones, and this is the XML structure. Suppose instead we essentially said, let's not do linked data. Instead, convince everybody to get themselves to publish their data as XML, right? Which is even an easier sell, because a lot of people do that. And then essentially say, you publish as XML plus some notion that somewhere you have a good, accessible XML schema, right? And now we have to expand that out a little bit. And then the semantic web community will, instead of taking the crappy RDF that people produce, take the nice XML, where you don't have this expectation of shared names, et cetera, et cetera, et cetera. Take this XML and do the tools, good versions of the tools, and meta descriptions. I hate saying meta anything, but anyway, meta descriptions that we can use to take this XML, which is perfectly good XML, and turn it into good RDF, as opposed to having them take the good XML and turn it into not very good RDF, which then they have to redo and clean up or whatever. Maybe that's a better story. And this linked data, reason to loathe the linked data story, it's encouraging people to do a bad XML to RDF translation.
So how much do the people in the linked data world believe that they've done enough? Do people believe they've done enough?
Yes.
They really believe it?
Yes. Not all of them. Bijan is going to say that.
Well, yeah, I mean, this was one of the things at the ISWIC keynote in Shanghai that MC brought up, is that right now everybody just thinks, I publish my data.
And I'm done.
And they're done. There's no, relatively little attempt to bring it back to any...
But will they find out that they haven't?
No, because they're going to write mashups, and they're going to use two linked data sources, theirs and somebody else that they talk to, okay? And they're going to create a nice mashup, and they're going to say, they're not going to make millions, okay? And they're great, okay? But where is, what have they done that's of interest in representation or anything else, right? They've taken two data sources. They could have been anything. They could have been XML. It could have been comma-separated values, and done a mashup out of it, right?
But you're contrasting two different things there. You're comparing useful to some people to interesting.
No, well, okay, so let me make it slightly different. So it's useful to this person who's creating this mashup. It's not useful to the next person who has to redo this all over again, right? Okay? If there's a story to be made, a good story to be made with linked data, it can't be that it's just a way of doing mashups between two separate or three separate sources. There's got to be some way of saying we are growing, right? So Tim Berners-Lee also has this talk about, what is it? It's sort of...
Wow, web, wow, it's awesome. Wow, awesome.
It's sort of... True, okay. But it's sort of as...
I've just given you every keynote for the past 12 years from
So here's actually something interesting. I don't believe it this way, but essentially, the first person to do something pays a horrible penalty. The second person pays a lot less penalty. The third person, a lot less, and eventually it's free. Right. Now, right. He has a way but essentially that's the argument, right? The trouble with, if we do this linked data thing this way that is for mashups, everybody's paying the same price. You're not getting any commonality over it. Commonality has to be you produce not maybe combining an arbitrary number of data sources, but many data sources you have no control over. All of this stuff, it's got to be worked that way as opposed to A versus A and B together, because they don't go from pairs to arbitrary numbers, right? Maybe you go from triples to arbitrary numbers, but if to be able to get the economies of scale that we really want, there has to be some way of doing this thing where the nth person is much easier, and I don't see that out of the pairwise matchup.
Any other questions? I think looking at the time, I'd say Peter will be around for the rest of the day.
And evening,
right? And evening, so feel free to pop around or arrange a time. Thank you.